In this video, I'm going to go over this homework question from the increasing, decreasing, and concavity assignment. So given this function, f of x equals 5x to the fourth minus 30x squared, we're supposed to determine where we are decreasing and concave down. So what we want is a double layer sign chart, which means I need to find my first derivative and second derivative critical values. So I'm going to start by taking my first derivative, which would be 20x cubed minus 60x. I'm going to set that equal to 0. I am going to factor out a 20x, and I would be left with x squared minus, it looks like 3 equals 0. So I'm going to set both of those equal to 0. And we're going to set the x squared minus 3 equal to 0. So this one would produce x equals 0. This one would give us x squared equals 3. When I take the square root, I'd get x equals plus or minus the square root of 3. So I know that some of my critical numbers are these right here. Now I need to take my second derivative and get critical numbers from that as well. So my second derivative would be 60x squared minus 60 equals 0. I'm going to factor out a 60, which leaves me with x squared minus 1 equals 0. So I'd have 60 equals 0, which produces nothing. X squared minus 1 equals 0, so x squared equals 1. And x equals, take the square root of both sides, plus or minus 1. So I just got 2 more critical numbers from that. So now what I'm going to do is I'm going to make a double layer sign chart. So I'm going to use all of these critical numbers in here. I know that this has to be between the square root of 1 and the square root of 4, so which is between 1 and 2. So I know that this has got to be either smaller than -1 or bigger than 1. So I know my intervals are going to be from negative infinity to this negative square root of 3, and then negative square root of 3 to -1, -1 to 0, 0 to 1, 1 to square root of 3, and square root of 3 to infinity. Next, I want to pick some x values that are in between here. So I'm going to go with -10. I'm going to guess that maybe -1. I don't know, maybe 1.1. I'm not really sure. I would have to put this into Desmos. Okay, so when I put square root of 3 into Desmos, I got 1.7. So I'm going to go with -1.5. It's not pretty, but it'll work. I'm going to go with -0.5, positive 0.5, -1.5, and positive 1.5 and positive 10. Okay, then I have to decide what is going on with my first derivative, what's going on with my second derivative, and then what is going on overall with my function. So I am going to plug into the most simplified version of my first derivative. And let's see, I noticed that when I plug in, I know that this is going to be, actually, so when I plug in the -10, I know that this is going to turn out to be negative, but -10 squared minus 3 is going to be positive. So a negative times a positive is negative. I'm going to plug in the -1.5. The -1.5 is negative. It's going to be negative here, and then it's going to be 2.25 is what you get when you square it. So it's going to also be negative here. So negative times a negative would be positive. All right, then we're going to plug in the 0.5. So when I plug -0.5 in, this would stay negative. This is still going to be -0.5 squared is 0.25, so that would still stay negative. So negative times a negative is still going to be positive. Now I'm going to plug in positive 0.5. So positive 0.5 here would be positive. Then I'm going to erase my scribbles. Positive 0.5 here would still be 0.25, so that's going to be negative coming out of here. So a positive times a negative would be negative. 1.5 would be positive here. 1.5 squared would be 2.25, so it's still going to be negative here. And then when I plug in a 10, it's going to be positive here. And then 10 squared minus that's going to be positive. So positive times a positive is positive. Now we're going to do that exact same thing, but this time we're going to look at the concavity. So I'm going to plug into this right here for my concavity. The first one I'm going to look at is negative 10. So negative 10 squared is definitely going to come out to be positive. Then I'm going to plug in negative 1.5. I know that negative 1.5 squared is 2.25, which is bigger than 1, so it's going to be positive. Negative 0.5 squared is 0.25. That's going to turn this into a negative, so it's got to be negative. And then 0.5 still is going to make that negative, so it's going to stay negative. When I plug in 1.5, I get 2.25, so it's going to be bigger than 1, so it would be positive. And 10 is definitely bigger than 1, so it's going to be positive. So the question was asking decreasing and concave down. So let's actually just determine what's going on here. So it looks like when I'm negative, I'm decreasing. Positive means concave up. Positive means increasing. Positive means concave up. Positive means increasing. Negative means concave down. Negative is decreasing and concave down. Decreasing and concave up. And then increasing and concave up. So in this case, it asked us for decreasing and concave down. So I'm looking for decreasing and concave down. Looks like it's only happening right there on this interval. So the interval would be from 0 to 1 is where it is decreasing and concave down.